There are different types of automotive relays. Mm. And relays can get damaged very easily, and that is one of the common cause of electrical fault in car or vehicles. So I was investigating what is really happening, why it is failing frequently. So this video is all about the investigation and some of the fixes for automotive relay. Uh, let's see why relay fails frequently or in many cars. So the the impedance of the, in fact, it's the resistance of the coil will be written on the top of the relay. Many relays may contain that resistance writing, but some relays may not have that written on the top. Okay, and that coil, so this is a damaged relay which I cut open, and this is the coil. This is very sensitive, and the impedance of this coil is written on the top of that. Since this is a DC operated device, this impedance means pure resistance. There is no inductive load on this relay. Okay, so we should be able to measure the impedance and see whether that is matching what is written on the top. So in this case it is written 85 ohms, and this relay got damaged, and I have another relay, and this is working condition, and this is also working condition. So let us see what is the actual impedance. Okay, if we measure it, you can see it is actually 54. Sorry, because of my hand. Yeah, 55 ohms. Okay, and if we measure this one, it is 58 ohms. So the what is mentioned on the top of many relays is not what we are getting. So the implication is that, see, if we have 12 volt supply, and if we have a 55 ohms resistance, this relay itself will start consuming 2.6 watts. But in many cases in the car power supply, because there is a alternator, the voltage may go up to 14.5, and then this relay will start consuming around 3.8 watts, and that is enough to heat up this coil on a long run. And since it's a sealed case, that heat won't go outside, and this gets damaged. And actually these two relays are such damaged coils. Okay, and I'm trying to add some protection for this relay. Okay, so I just open this case. This is not that high quality relay, but yeah, it's let me try putting some protection mechanism. And interestingly, these relays doesn't contain even a flyback diode. So there is a high voltage getting generated also. So let us add some protection and for the car as well as the relay. If we closely inspect, we can see that one end of the coil is connected to this terminal. So my first effort is to detach that coil from here and add a protection resistor, so that I can bring the total resistance to somewhere around 85 or 86, that range. That resistor will act as a current limiting resistor, so that this coil will be much better protected. First I added a 33 ohm resistor in series to this coil. The coil is end is detached from here, and the end is now available here. So this resistor is in series with this coil. So the total impedance comes to around 88 ohms. This should be sufficient, and I tested, the relay is working fine. Okay, now I am going to add flyback diode. A fast recovery diode 1N4148 is taken, and put that into sleeves. After connecting the flyback diode, it looks like this. The flyback diode edge is here, and here is a series resistor, and the flyback diode is going to the other end of the coil. So basically both the end of the coil is connected by flyback diode. Okay, and now the cap can be fitted. After that I sealed the relay using some tapes so that the back won't come off easily. Now let us see how much of resistance it shows. Okay, 90 ohms. So from 55 ohms to 90 ohms. So this conducts less current and it works better, and this has a flyback diode also, which can protect the car circuitry. So now let's see how it works in the car. After inserting the new relay here, it started working, and as we can see, okay, let me switch on the power. Yes, now the power socket started working. Okay,